Alright, so I'm going to be going over the highlighted problems on the test 4.2 review. The test tomorrow is 8 questions instead of our regular 12 just because of the amount of time that each question is going to take you, but that does mean that each question is weighted more. So it is 8 questions, 8 points apiece, and then your work will be worth 36 points on a test. On the review, you can see here that the last page is the odd answers for the review. So you have the answers to all the odd questions. And so I am going to be doing 5 of them, leaving you 15 to do on your own. So on the first section, we are sketching the graph and then stating the zeros and the number of turning points. On number 1, we have this function 2x squared plus 8x plus 4. Remember, when we are factoring, the first thing we want to do is find a GCF if we can. And on number 1, I can divide each of those terms by 2. So we get f of x equals 2 times x squared plus 4x plus 2. So then I can factor that quadratic in the parentheses of x squared plus 4x plus 2. So we would need two numbers that multiply to 2 and add to 4. And because 2 is a prime number, the only way I can get to 2 is by 2 and 1. 2 plus 1 is 3. So unfortunately, we can try to factor, but we're not going to be able to factor x squared plus 4x plus 2. So my alternative to factoring when I want to find the zeros is to use the quadratic equation. And so we use the quadratic equation when we have something of the form ax squared plus bx plus c is equal to 0. So we would set x squared plus 4x plus 2 equal to 0. And so we have x would equal negative b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2a. So that's what I'm going to do with that x squared plus 4x plus 2. So I'm going to say x equals negative b, so negative 4, plus or minus the square root of b squared, 16, minus 4, times a, which is 1, times c, which is 2. And that's all over 2 times 1. Negative 4 plus or minus the square root of 16 minus 8, which is 8 over 2. Square root of 8 is 2 root 2. And so I can reduce that to negative 2 plus or minus square root of 2. And so I am going to approximate that just so I can get the zeros. Negative 2 plus the square root of 2 is approximately negative 0.586, and then negative 2 minus the square root of 2 is approximately negative 3.414. And so I just got that from putting it into the calculator. Now, when we are graphing, we want to know what direction it is facing. And so this is a quadratic, so it's going to face the same direction on either side. We know our quadratics either look like this or they look like this. And that depends on whether the first number is positive or negative. Our first number is positive, so we're going to have a quadratic that is facing up, with zeros at these approximate points, so negative 3.414 will be somewhere over here, and then negative 0.586 would be somewhere over here. And we can find the vertex, but I'm not going to worry too much about finding the vertex just because this isn't a quadratics test, and all it says is to sketch the graph, and you would have your calculators available to you on the test, so finding the vertex exactly is not of importance for the test tomorrow if you're given a quadratic. What you do want to find are the zeros, which we did, and then it says the number of turning points. So remember, a turning point is where the graph changes from increasing to decreasing or decreasing to increasing. So wherever the graph changes direction, that's a turning point. And so if we're following along on our graph, we start over here, we're decreasing, and then all of a sudden we get to this point down here and we're increasing. So our graph has one turning point. The next one I'm going to do is number 5, and so we have f of x equals x cubed minus 3x squared. So I want to take out a GCF if I can, and I see that they both have a power of x. So I'm going to take out the smallest power between them, which would be an x squared, and I'm left with x minus 3. So in order to find my zeros, I would take each of those and set it equal to 0. So x equals 0, and we have x minus 3 equals 0, which tells me x equals positive 3. So x is 0 and positive 3. And this is a cubic function, so I'm going to look at the degree, which is 3, and that's odd. And the lead coefficient, which is 1, and that's positive. So positive tells me it'll end up, and odd tells me they'll be opposites, so my end behavior would be down and up. Order does matter. So my end behavior is down and up, and those are my zeros on the graph there. So then what I will do is make a sketch of my graph. So I need my graph to hit this point because it has a multiplicity of 2, and then go through that point. So remember what our multiplicities do to our graphs. Multiplicity of 2 here. So we're going to bounce through that point, not go straight through it, and then on the other one, the 3, we're going to go straight through it. So when we're finding the number of turning points, we are increasing, then we're decreasing, then we're increasing. So we have increasing, decreasing, increasing. So that means we have 2 turning points. And those turning points we can find right here and right here. Now in the next section, we're finding the roots of these functions. So on half of them, they are already factored for you, and then on the other half, they are not. So I'm going to do one of each. On number 7, just be aware that roots can also be called solutions or zeros. And you'll likely see it all 3 ways tomorrow on the test. So just be aware that it all means the same thing. You're finding the zeros of the graph, the x-intercepts. So on number 7, when it is factored already, we'll take each factor and set it equal to 0 and solve. We get x is equal to -2. And then same thing over here. 2x squared minus 5 equals 0. Add 5. 2x squared equals 5. Divide by 2. X squared equals 5/2. And then take the square root. X equals the square root of 5 over the square root of 2. If we want to rationalize, we'll multiply by the denominator over itself. And so we get the square root of 10 over 2. Plus or minus whenever we have the square root of something. And if you don't know how to rationalize at this step, then just put what you get here into the calculator and look for whatever decimal matches on your multiple choice. It should be plus or minus. And then on number 13, we have 4 terms. And I know that whenever I have 4 terms, what I'm going to do is split the problem in half and try to factor both sides. On the left side, I have an x squared in common, which would leave me with 3x plus 1. And on the right side, I don't see anything in common, 3x and 1. So what I can take out is a positive 1 and just leave it the same. And so I end up with those two the same, which is what I want. X squared plus 1 and 3x plus 1 equals 0. And then I'll set each of my factors equal to 0. So x squared plus 1 equals 0 is the first one. And we will subtract 1. X squared equals -1. Take the square root of both sides. X equals positive and negative. The square root of -1 is I. So we would have plus I and minus I. And then 3x plus 1 equals 0. Then we'll solve that for x. So x equals -1/3. And so the number of zeros usually is the highest degree. So we should have 3 zeros. With the plus and minus I, we have 2 separate zeros. We have positive I and negative I, and then we have -1/3. So we have all 3 of our zeros accounted for. And then lastly, we're going to write the polynomial function of least degree with integral coefficients that has the given zeros, which just means we want to write our polynomial function given these zeros. And on the test, it does ask for standard form, not factored. So we will have to multiply it out. But we're pros at multiplying it out because that's what we did on the last test. So on number 20, our function would equal, from 0 we just get an x. From -5/2, I'm going to have to find that one. And +2, I'll take the opposite for the factor, and x minus 2. Now with x equals -5/2, I want to move that over to where it's no longer a function and to where it equals 0. So I would multiply by 2. Did I say no longer a function? I meant no longer a fraction. And so 2x equals -5. Remember, I still want this to equal 0, so I'll add that 5. And 2x plus 5 equals 0. If you don't trust that you did that correctly, then what you can do is solve it from there. And I would say 2x plus 5 equals 0, and subtract 5 as my first step. 2x would equal -5, divide by 2, and x equals negative 5 over 2. And that's what I started with, so I did make that into a factor correctly. So 2x plus 5. So remember, we want it in standard form, so I have it in factored form there, and I'm going to multiply out my polynomial. I'm going to multiply these two first because the easiest step is going to be multiplying everything by x, because we'll just increase every power of x by 1. So I'm going to take 2x plus 5 and multiply it by x minus 2. So 2x times both of those terms, 2x times x is 2x squared. 2x times negative 2 is negative 4x. 5 times x is 5x. 5 times negative 2 is negative 10. I have like terms in the middle there. So 2x squared minus 4x plus 5x, which is 1x, and then minus 10. But I still have that x that I need to multiply that entire thing by, so I'll take 2x squared plus x minus 10, multiply it by x, which just raises the power on each. So 2x cubed plus x squared minus 10x. And if you needed to check if you were correct, you could graph your function and find the zeros. And if your zeros match the zeros you were given, 0, negative 5 over 2, and 2, then you know that your function is correct. But that's just if you have a little bit of extra time to check your answers. So these are the ones that I will be covering today, and then as always, if you need any extra help, feel free to reach out to any one of us, and we are happy to help you. We are happy to open up a Zoom or do whatever you need to be successful. So work on the remaining 15, make sure that you turn this in, and then study up for your test tomorrow.